Welcome to the STEM Lyceums Clean and Renewable Energy event. Theme is Clean and Renewable Energy. A little bit about the Center of Excellence for Education. We are a Virginia-based nonprofit that was founded in 1983 by the late Admiral H.G. Rickover, who is considered father of the nuclear navy and civilian uses of nuclear power. And also the co-founder is Joanne DeGennaro, the president. We have a mission at the center to nurture high school and university students to careers of excellence and leadership in STEM, and also encourage collaboration between and among scientific and technological leaders in the global community. STEM Lyceums, which is the program that is hosting today's event, has a mission to engage students in discussions and explorations of STEM concepts and STEM career pathways. My name is Laura Ashley, and I am the program manager for STEM Lyceums. I will be hosting today's event. So at this time, I would love to introduce, and please introduce, our two speakers for today's event, Paula Sanjines, who is a professional engineer, and Jeffrey Sampson. Paula Sanjines is a professional engineer, like I said before, and she is also a senior wastewater treatment technologist with over 20 years of experience in the planning, design, construction, and operation of wastewater treatment systems. She has focused her career on the development and implementation of advanced wastewater treatment technologies for nutrient removal and resource recovery. And she has also worked on climate change action plans and adaptation strategies for several utilities. Our second speaker is going to be Jeffrey Sampson. He is a construction project manager in the Project Construction Renewable Energy Group at Dominion Energy. Jeffrey obtained his bachelor's in electrical engineering from Old Dominion University, ODU. At Dominion Energy, he leads the pre-construction team consisting of project leaders, project engineers, permitting specialists, and performance engineers in support of utility-scale solar generation project permitting for the transmission and distribution interconnected projects. Additionally, he has over 25 years of experience managing site construction of utility-scale solar generation facilities for Dominion Energy and large-scale capital projects as a manufacturing engineering manager in both the automotive and heavy industrial industries. So you're going to hear about their STEM journeys and what they currently do in the field of clean and renewable energy. So I'm going to turn it over to Paula, who is going to present first.
Well, thank you for that great introduction. So I'm going to talk about renewable energy from waste today. My name is Paula Sanjines. I live in Tacoma Park, Maryland, and I work for Jacobs Engineering, which is an engineering design and consulting firm. And I work on the design of wastewater treatment systems, and that's what I'm going to talk to you guys about today. So first, I'm going to go through a little bit what my journey has been as far as becoming an engineer. And then I'm going to talk a little bit more in detail about some of the technologies that we use to clean the wastewater and extract energy from waste. So my STEM story begins in Bogota, Colombia, which is where I was born and raised. And growing up there, there's a river that goes through Bogota, which is named the Bogota River, not very original. It's very polluted, very dirty, a lot of trash, a lot of untreated sewage gets discharged to the river. And, you know, growing up, we would kind of drive by the river on our way out of town, and it always smelled terrible. We actually used to tease my little sister, you know, that she had, you know, farted, and she'd be like, no, I didn't. I'd be like, yes, you did. It would make her cry. And the river being so dirty also made me cry because it was just so nasty and gross. And so, you know, I remember at that, you know, at that young age, just being very concerned about the environment and water, but also just having a sense of like not knowing what to do about it. Like it just seemed like such a big problem, and how are you going to clean this up? And it was just like, you know, beyond me at that time. So then I moved to the States with my family, and I really enjoyed math and science. And in high school, I did pretty well in math and science. So that was good, and I just really enjoyed it. Kind of came easy to me, which, you know, of course, made me enjoy it even more because I didn't have to study too hard, whereas some of the other subjects I did. I also realized that I really enjoyed kind of figuring things out. I wasn't very good at things where I had to kind of memorize a lot of things, but if you kind of gave me a kind of a puzzle or a problem, I kind of enjoyed figuring out how to solve it. So when I started college, I wasn't sure what to major in. I was like, I kind of want to do engineering, but not sure what kind. So I read somewhere that, chemical engineering at the time, I don't think this is true anymore, you made the highest salary out of school. I was like, oh, well, there you go. Let's just go after the money. So I started engineering school, and it was hard, man. It was hard. The classes were really hard. Like I said, in high school, I had done well. I hadn't really had to study much because it just kind of came easy to me. I kind of got it right away. But college got a lot harder, and the classes were a lot bigger. And, I may or may not have been fully awake by the time the classes came around. So my grades were not so fantastic. And I was like, I might cut out for this. Is this really what I want to do? I'm not sure. But I didn't really know what else to do. So I was like, well, let's keep on plowing through, see what happens. One thing that really helped me was I found a study group. I realized that I really enjoyed kind of solving problems with a group. And just kind of that collaborative environment really helped me a lot. And the people that I studied with were great, were very encouraging, very helpful. And it kind of helped me realize that, we were all struggling, right? Because sometimes when you're in college, you're like, oh, it's just me, like I'm the only one who's struggling, right? But just being around other people and just seeing that you're just, same as everybody else really helped me. And then I took a hydraulics class in college, basically learning how water moves through pipes. And I was like, oh, water, like I remember, like this is what I really enjoyed. So that was good. And then I kind of had an aha moment, right? Because I took a class where they taught me how you could clean the water. And it's like, oh, okay, this is what I want to do. So that all kind of came together for me. And definitely my last 2 years in college, from junior and senior years, I just was a lot more motivated, and I decided to stay an extra year and get a master's. So I graduated with a BS in chemical engineering and a master's in environmental engineering. And then after a little bit of some twists and turns, I ended up getting the job that I have today. I have different positions, but with the same company. So what do I do now? I plan, I design, I build wastewater treatment systems. So this is a picture of the wastewater treatment plant here in Washington, D.C. It's called Blue Plains, and you can see the Potomac River there in the back. So how do we clean wastewater? So I'm an engineer, so I like to do things kind of in order. So starting where does it come from, right? So water, comes into your house, your clean water comes in, and you use it in your bathroom, in your shower, in your toilet, in your kitchen, in your laundry room, and then the dirty water comes out. How do we clean the wastewater? And so then we get water from houses, from buildings, from schools, all that stuff. Sometimes we have, industries that discharge water into the municipal sewer system, but usually they are required to meet some type of pretreatment requirement ahead of time. We don't let them just dump like nasty stuff into the sewer. And then it goes into the treatment process. Okay. This is the most important part of my presentation, okay? So if anybody's paying attention, this is, if nothing else, this is the one thing to remember. Do not flush wipes down the toilet, okay? They might make it down the toilet, but then they go down the pipe and they become these nasty masses of stuff, and then like grease from the kitchen gets congealed in there and all sorts of other nasty stuff. And somebody has to go in there, usually a municipal worker, and they have to clean out this mess. So do not flush wipes. Even though they say flushable, don't flush them, okay? Just put them in the trash. Okay, that's all you have to remember from today is that. Okay, so first we have to pump the water, lift it to the treatment processes. Again, if there's a bunch of rags and wipes in there, it clogs the pumps. It's not good. Then we put it through screens in order to protect the equipment further down. So again, don't flush those baby wipes. And then we let the water sit in very quiet areas. We let the solids kind of drop to the bottom of these tanks, and then at the bottom we kind of collect all the solids. The clean water kind of goes over these weirs you can see here. Then we take that water and we put it into our biological treatment. And so basically we use bacteria to eat up dissolved carbon, nitrogen, and phosphorus in the water. There's some pictures of some of the bacteria that help us out. And basically, as engineers, what we do is we design these biological reactor basins to provide the optimal conditions for the bacteria we want to grow. So some of the bacteria like air, so they need dissolved oxygen. So we have to size the systems and we have to put air in to keep it aerated. And then in other areas, we let the system go anoxic, so with no air. So other types of bacteria can take over. So that's how we kind of control which bacteria grow in different parts of the reactor. Then after that, we take we go through another process like this where we settle and we send the bacteria back to the biological reactor, and then the clarified water then goes into the filtration step. Some plants have filtration, some don't. Depends on kind of what your final effluent requirements are, usually set by your state. But the filtration removes the last of the particles in the water. And then finally, we disinfect the water before we release it. In this case, we use UV light to inactivate all the bacteria. Some other facilities use chlorine, either, usually like a bleach solution, but then they have to take the bleach out because obviously the fish don't want to have a bunch of chlorine thrown on them. And then the clean water usually gets, released to a river or a lake or the ocean in many cases, but it can also be reused. So some uses this for like irrigation, for cooling towers, also sometimes to recharge aquifers. So if you see this kind of purple sign, recycle water in use, don't drink it, don't wash your hands with it, but do be happy and thankful that that water is getting reused and being put to a good application. Okay. So what do we do with the solids that remain? They are not waste, okay? They're full of energy and they're a valuable resource. So if you think about it, we eat food to give us energy, but let's face facts, we don't use all the energy in all the food we eat. Maybe if you're like an ultramarathoner, maybe, but even then, a lot of the energy just kind of goes through your body and it ends up in the wastewater treatment plant, right? So we have all the energy and we collect it and we put it in a digester, okay? And there, again, we use bacteria to help us digest the complex carbohydrates, produce methane gas, and then that gas gets cleaned up and we can use it for various things. So traditionally, we've been using it in generators to produce electricity and heat. Increasingly, it's also being used in liquefied natural gas or concentrated natural gas to power buses and any other renewable natural gas uses for it. The anaerobic digestion process is also a biological process, and some places use anaerobic, other places use aerobic. So the biology is a little bit different, but at the end of the day, what we're trying to do is basically keep all these bugs happy and in the right balance so that they are giving us the methane gas that we need. Here's an extra digester, and there's a picture of a generator in case you wonder what it looks like. And then finally, with the solids that remain, we treat them and we use them as fertilizer. In some cases, ideally, that's what you do. In other cases, sometimes they just put them in the landfill or just discharge them in other ways. In other places, sometimes they burn them, they incinerate them. But they're very rich in nutrients. They have a lot of nitrogen and phosphorus, and it's a good source of nutrients for plants. So what does an environmental engineer do? What do I do? This is all fantastic, but what do you actually do? So we do planning. So we come up with basically technical solutions to environmental problems. So one example, for example, is how do we improve the biogas production of the anaerobic digestion process, right? Can we maybe pre-treat the solids before they go into the digesters in order to break down some of those complex carbohydrates a little bit more to get more gas out of the process and things like that. Then we design. So when we design, you want to size the systems, you want to develop process flow diagrams, right? Because wastewater treatment plants have to operate 24/7. The water keeps on coming, right? Nobody can tell people not to flush the toilets. Just take a break. Just keeps on coming. So you have to do flow balances and mass balances to make sure that Everything can move through under a variety of different conditions, and you have to select what type of equipment to use, and what size, how big the pipes, how big the valves, all that. Then we build it, and during the construction process, we work to make sure that what is being built is what we designed, right? And obviously, problems come up, and we have to help solve them and make sure that at the end of the day, what is built is going to work for to address the issue. Then we help operate. So we test the equipment, make sure that everything works as intended, and then to help troubleshoot if things don't work right. And just in closing, some of the skills that help you be a good environmental engineer, obviously you have to like math and science. Attention to detail is good, because you have to be very thorough in everything you do. And having also good problem solving skills, because the unthinkable can and will happen. Having good logical thinking, if this, then that, kind of putting a puzzle together. Obviously computer skills. So we use, word processors, Excel, being able to do graphs, being able to analyze data. Well, that is very important. We also work with a lot of models, but that tends to get kind of more on the job training for that kind of stuff. And the most important two things I would say is you have to be good at communicating, because you want to explain why you think things should be done a certain way. And you also have to document your thought process and your decisions. So you have to be a good writer. You have to write be able to be just very, very clear on what you're doing and presenting. And you can be the judge of whether I did a good job or not. But this is the kind of thing we do all the time with our clients. We also have to be good at working in teams. Because we work as it. So that is all I had, and do not flush the lights.
Thank you so much, Paula. That was a great presentation. I love wastewater treatment. I love water filtration. I love everything environmental engineering. So I thought it was a really cool presentation, and it was nice to have like a good review of all of the stuff that I learned a long time ago. But yeah, of all of the stuff that I learned a long time ago. But yeah. Okay, so at this time, I am going to turn it over to Jeffrey Simpson, who will talk about his journey in STEM, as well as his current work at Dominion Energy.
Again, I'm Jeffrey Sampson, and I'm a construction project manager here at Dominion Energy. I run our permitting group to acquire land disturbing and construction permits, which include stormwater and some others for us to get started on building solar energy facilities here in the state of Virginia. Right now we have a lot of projects that are in the process of getting permits. I have about 18 projects right now that are in various stages of permitting to go into construction, and we have a lot of other projects that are already in construction. I've been doing this for about a year now. I started with Dominion Energy in the field with doing managing construction of these large scale projects. So I'll go ahead to the next slide here and tell you about my story and my career path. So I have an electrical engineering degree from Old Dominion University down in Norfolk, Virginia. Again, like Paula, I kind of felt high school wasn't that challenging for me, and wow, when I went into engineering school at Old Dominion, it was tough. So I had to work hard. I didn't have a lot of funding to school. My parents didn't have the money to pay for me for tuition and things. So I had to work. So I've been working since I've had my driver's license here in the state of Virginia, saving money. I would go to school one semester full time and work part-time, and then I would go and take a semester off so I could work full-time to save up enough money to pay for the next semester for books and tuition. That was a long time ago. It was a lot of money for me at the time to do that, but it took me 6.5 years to get through school. But I made it through, had my bachelor's degree in electrical engineering. And so really quick, not to talk about the economy, but back when I got out of college in the late 80s, the country was just coming out of a recession, and there weren't many jobs. I worked as a carpenter. That was one of my part-time jobs I did when I was in college for a few months. And actually I went to work for the Navy for 6 years before joining Ford Motor Company. I spent 10 years at Ford Motor Company, as a manufacturing engineering manager at several different assembly plants. Started at the Norfolk Assembly Plant, which we built F-150s there in Norfolk, Virginia. Spent about 5 years there. Went to Michigan Truck Plant in Wayne, Michigan, right outside of Dearborn, and worked up there managing maintenance, engineering, and their production groups to support production there for manufacturing of expeditions and navigators. Did that for about 2 years, and then got moved back to Norfolk Assembly Plant, and was the manufacturing engineering manager there through about another 3 more years or so. And then I decided it was time after 10 years to start my own business. So I started my own business. I had several businesses that I owned there in Yorktown, Virginia. One was called Motorsports Engineering Incorporated. The other was JSI Marine Construction. So in the course of learning, how to do engineering, how to develop processes, how to solve problems, how to figure out things for yourself. I was applying all those things. I built a lot of equipment in the motorsports engineering group. I had 3 people employed there. We built race cars. We built suspension parts for race cars. We had shock dyno, spring dyno. We started building engines and then kind of got away from that. But we would put engines on a dyno and test our engines before they go into the cars. Along with that, and in conjunction at the same time, marine construction business, I had built some equipment. I had a steel barge and some, a couple boats, and we were building piers, boat houses, anything out on the water that driving pilings in and building a pier out on the water for residential properties around Newport News, Hampton, Poquoson, down on the York River, Warwick River, James River, Back River. So we were very busy for a long time. And then the economy went sour again in around 2008, 2009 time period. So had to close my business. Went back to work in my profession as electrical engineer and my experience in engineering and maintenance. And I was a plant engineering and maintenance manager at the Alcoa helmet castings plant there in Hampton. And then spent some time with Alaris Robotics in Richmond, which kind of led me to where I am today as a construction project manager on utility scale production of facilities up here in Richmond for Dominion Energy. So I'll kind of give you some ideas of things that I did. So at Ford Motor Company, as you can see, there was a large amount of automation. So you can take and apply a lot of engineering skills that you learn in engineering courses with automation. And you can see here on the left, there's robots. These are welding robots. So not only is the process automated, you have conveyor systems that move parts from one step to the next step, and each robot does a different task. Once the bodies and things are put together, they go through the paint shop, which is highly automated. And then you can see on the right where they're actually putting a cab onto a chassis with the engine already mounted, wheels already mounted on the chassis in the plant. So this gives you kind of a really good idea of how to apply skills that you learn in engineering and how to make it applicable to a production facility. So next slide, please. So in my business, motorsports engineering, this is actually up here on the top left, an engine that I built that went into that number 8 car right there on the top right. This was on the engine dyno. Maybe it's a little difficult to see, but we have temperature sensors on all of the exhaust ports on the engine. We have sensors for valve timing and all other things, engine timing. And we get the best performance we can out of an engine before it goes into the race car. Down on the bottom left, you can see after we install it into the car, what it would look like into the car. All of these things are just hand-developed, handmade. These are not production vehicles. These are things that we made in our shop. On the bottom left there, it's a really good picture of two different vehicles that I raced, a late model stock car on the left, and then a full-size truck, like a Craftsman truck that you would see on TV there on the left, on the bottom. So just gives you a really idea. We made the bodies for the vehicles. So these are not stock bodies. These are handmade bodies that you see on these vehicles. So there's a lot of engineering principles that go into how do you bend metal, how do you de-stress the metal, how do you shape it, form it, get it to the way that you want it to make it look like the end product, which is a vehicle. So this is something we did in my business. Next slide is an example of a casting at Alcoa. We made industrial gas turbine parts there. A very prioritized process where you would melt metal in a vacuum. Certain metals that are used, like nickel-based alloys and titanium-based alloys, are highly sensitive to oxidation. When you melt them and you get them up to a high temperature that you see here, here's a casting in a mold that's just coming out of the furnace, and you can see how hot it is and how you have to protect yourself from the heat. This is a manufacturing plant here in Hampton, Virginia. So just example of the type of facilities that I manage there at Alcoa. So this is a project I built back in 2016. This is up in Powhatan County, Virginia. This is a Dominion Energy project. This is a 20 megawatt solar site. It's kind of hard to see, but you can see like little tiny little white boxes along the center line of the project there. Those are the inverter transformer skids that take all of those solar panels there, which is about 45,000 solar panels that you can see. They're all connected up to those white boxes that take all the DC power from the solar panels and convert it to AC. That AC power from the transformers, and there's 9 of them. You can only see 8 right in this picture, but there's 9 of them on this project. They collect that AC and take it to a switching station, which ties it to the grid. So this is how we convert sunlight to usable power you use in your home. Just to give you some perspective of how big and what disciplines that we use to build solar projects, our projects are anywhere between 20 to 300 megawatts in size. We use from about 200 to approximately 3,500 acres. We have 40,000 to 600,000 modules on one of these projects. The size of one of those solar panels is what we call modules. Is about 2.5 foot by 5 foot. So they're pretty good size. So our AC distribution voltage is 34,500 volts. And on our transmission connected projects, it ranges anywhere from the transmission voltage between 69,000 and 500,000 volts. The engineering disciplines that we use to construct a solar site is all civil, electrical, and mechanical. I would say about 70% of our work is civil engineering work, where we have to take the acres that we have, and we have to develop a Virginia regulatory compliant stormwater plan that has controls with ponds, outlet structures in those ponds that controls the water quantity and quality as it re-enters the receiving areas, typically wetlands around our projects. And we restore vegetation, so our sites are fully vegetated when we go into commercial operation. A lot of the electrical engineering disciplines that are used in constructing a solar site is we have to size cables, depending on how far away you are, how much current you're going to be pulling through those cables. We have transformer design. A lot of the controls are all unique and very specific for each project that we have to design. And as of late here, we have implemented an enormous amount of cybersecurity protection in all of our sites. We are required by federal requirements and law to maintain security for the power systems and power grids, because we are a generation company. We generate power and we have to secure that. Mechanical engineering methods that are used are, there's a lot of wind load structural analysis that has to be done, along with substation support steel foundation designs for very heavy transformers and inverter skids. We use a lot of racking for PV modules because our modules track the sun, so they point east in the morning and they totally track all the way over to the west in the evening. So we're constantly pointing our modules at the sun. So I just wanted to cover some opportunities that you can, look at is, how can I be involved in career opportunities that Dominion Energy has. In engineering, we've talked about electrical, mechanical, civil engineering. A lot of what we're doing now has to do with information technology and system engineering, how we interconnect these facilities to existing transmission lines and distribution lines and circuits that are already out there, and how we transition between and control whether we're using a nuclear facility or a coal or a gas-fired plant, because a solar site only works during the day when the sun is up. So at nighttime, we're not able to produce power, so there has to be seamless transitions from when we're using solar power to other sources of power, so you don't ever see a change in your availability of your power to your home. There's also growth technology. There's a lot of PV module efficiencies and development going on. 5 years ago, we were using modules of about 200 watts each. Now we're using bifacial modules that are about 585 watts each. We have new tracker systems that are more efficient in tracking the sun. We are just starting to implement utility scales energy storage, where we're putting in these large battery systems. The previous picture I showed you was one of our pilot facilities where we installed these large containers. They're the size of a tractor trailer, but it's a battery that we hook up to the inverters, and they would charge during the day and then they would discharge during the night. There's a lot of mathematics used in development of our projects. We do energy modeling before we build projects, and also to compare our modeling versus what we're actually producing on the project. We do interconnection studies, how these solar sites interact with existing transmission and distribution lines. And along with that, has a possibility to create harmonics in the system, which you would never see, but it affects the performance of our transformers and our substations. At Dominion Energy, we do offer internships in engineering. Those include like power distribution, transmission opportunities, environmental compliance opportunities, and along with substation design opportunities. So this is my question to you. Moving forward, what can you do to reduce or offset your daily carbon footprint with renewable energy resources and the actions you take to recycle everything you use in your daily life activities? I know that may be tough to really understand how much of a carbon footprint that you use, but when you take your phone and you plug it in and you charge that phone up, that power has to come from somewhere. That power is generated from a renewable source. It can be generated from a gas-fired plant, a nuclear plant, or some other biofuel plant. You're not really sure, but you do have available power to you and you are consuming it. So just think of ways of how you can reduce. This is an advertisement that Dominion has used on their website for renewable energies. That's a picture of me. It's from the back. This was a project I built in 2017 in Buckingham County, Virginia. They use this on a lot of promotions. I just happen to be the lucky person that got filmed for this picture, but I just wanted to actually show from a ground point of view of, what a solar project actually looks like in the field. So thank you so much, Lori Ashley, for the opportunity to present here this afternoon. So I think you're probably ready for questions. So Paul and I'm sure, are ready for your questions. Thank you.
Thank you. We do have a question, and I want to also give our audience the opportunity to try to think of questions they might have had during both your presentations. But I have one before I want to ask the question that we have, and that's you all do a lot, like in your jobs. You work on teams, you work with a lot of people. I'm just interested on, this is my own personal question, what would you say is kind of, I don't think you have to use an exact scenario, just one of the most difficult things about your day that you experience, whether it's like a project you worked on, just something that was really difficult to accomplish or manage?
Yeah, a recent example is we are working on a large project in the city of Alexandria, Virginia, where we're building a large tunnel system so that when it rains, because Alton Alexandria is a very old city, right? It was built back in the 1700s, 1600s, 1700s. And so back then, the sewers and the stormwater all went into the same pipe. So when it rains, the water overflows into the Potomac River. But because it's an old city, you can't go in, and it's like you can go in and dig out all the pipes and put in new ones, right? That's not doable. So we're building a big tunnel below ground to capture all that rainwater. And then we're designing a big pump station on the other side next to the wastewater treatment plant, where we're going to pump that water and then treat it. So it's been fun. It's been a fun project. It's been fun getting back into design, but a lot of different disciplines, right? So we have geotechnical engineers, structural engineers, electrical engineers, instrumentation and control engineers, process. We also have a building, right, that houses the pump station. So we have HVAC engineers, we have plumbing, we have all these different disciplines. We have an architect. So just coordinating amongst all those disciplines is challenging. And the way we work is we create a set of plans of how the thing is going to build, and each set of plans has different disciplines, right? So there's the architectural drawings, the structural, the site civil, right? All the pipes that are in the yard, the process, the mechanical, and all that. And we just have to coordinate that everything. We're at the point now where everything has to be coordinated. So if one discipline is running behind, right? If, for example, our structurals are still not quite there with what they need to do. And so I'm waiting to size this door opening so they can go in and fix some equipment. But I can't do that until my structural engineer figures out where his beams are, so just a lot of coordination across disciplines like that. And just having to constantly keep a running list of all the things that you need to coordinate with other disciplines is challenging. And of course, not being in the office, being virtual, has also made that a little bit more difficult, because when we were all in the office, I could just walk down to my structural engineer's office and be like, hey, I need to figure this out. And, I can still call him on Zoom, but it's just not the same interaction.
Thank you. Thanks, Paula. Jeffrey, do you have want to, answer?
Yeah, I do. I have to echo what Paula is saying here. What I was thinking of when she started speaking is my biggest challenge on a daily basis. I have a team of 12, and we have basically 18 different projects that we are. These are very large scale projects in total of almost $1.5 billion worth of work that we are currently trying to permit right now. The biggest challenge I have is my team communicating in an effective manner. As Paula stated, I get more accomplished with a 5-minute conversation with someone than I would probably 15 emails, because I don't understand the tone or the demeanor or the real meaning of an email. And I have to ask, well, did you mean this or did you mean that? Where when you have a conversation, and I think we've kind of lost the art of having a personal conversation and developing relationships So when you have an issue that some people see as stressful, when you have a personal relationship with that person, it's a lot easier conversation to have when you have a personal touch and can actually sit down and smile and let them know that we're going to work through this and this is not as bad as you think. And I think that's just my biggest challenge with my team, is to get them to understand that, you know, the more you communicate and the more effective you communicate, the less the stress is in the organization, which means you're more productive in your work.
Really great answer, because yeah, from what it seems like both of you all do, or from what both of you all do, it's definitely apparent that you work with a large group of people, and everyone's job is intertwined, and there's a lot of dependency there. So having really clear-cut communication is a huge skill that I think, aside from just the numbers and the math, like engineering, a lot of people don't realize
Right. That's
what a lot of engineering entails, is really good and effective communication skills. So thank you both for that. So I'll jump into the Q&A. Our first question is, what did you look for when picking your college, and what was the best part about the college experience? Either Paula or Jeffrey, you can answer first.
Yeah, I'll go, Paula, if you'd like. So for me, I did not get to go to the school I wanted to go to. I wanted to go to Virginia Tech, and so I applied and I was accepted, and I just couldn't afford it. It was a financial decision for me. I had friends. I already had a roommate picked out. I had, you know, friends going to Virginia Tech, and I just couldn't afford it. Old Dominion University was about a 45-minute drive for me each way, every day. I could live at home. The tuition was cheaper, and it was something that I could work on a regular basis to be able to pay for my school as I got through school. I wouldn't have been able to to receive my degree if I didn't have that opportunity to work. So, you know, I'm thankful that the opportunity was close enough to me where I could actually drive to school and do that. But it was a financial decision for me.
Yeah, I actually did get into the school I wanted to go to, and I went to Stanford University in California, which was great. But it was hard because it was just a very difficult school, and it was also one of these liberal arts schools where you just come in as a kind of general major. And I didn't do well in such a kind of open field environment. I feel like I did a lot better once I kind of figured out what I wanted to do, what my major was, once I was in smaller classes with people who were doing the same thing I was doing. So recently, my son is a junior in high school, and we just visited Cal Poly out in California, and they were talking about how it's a lot more like kind of hands-on type of learning from the get-go, which I think maybe that would have been a better environment for me, just somewhere where you kind of, I felt like I did better when I was in smaller classes, and also more applied, because I think all the theoretical stuff for me sometimes was just a little bit kind of too out there. And I did much better when I was like, oh, okay, this is how you use that information. This is how I'm learning this physics, because this is how it gets used. Like I was more of a practical person in that sense. All over the place, they're going to invest in a lot of infrastructure. But also, it's interesting because Jeffrey mentioned, for example, a lot of his projects, right? You guys need stormwater design and treatment. So that's something also that environmental engineers do, is working in that. So we also work in like transportation projects, like a big highway is getting built, and they need to make sure that the stormwater is managed correctly, or a large project like the ones that Jeffrey manages. So yeah, there are a lot of opportunities. I would definitely recommend doing like internships while you're in college, and kind of getting connected with the industry, participating in the student chapters of the various water associations. There's the American Water Works Association and the Water Environment Federation. So getting involved with student chapters and just networking, because the jobs are out there, but it's it's not like with electrical engineering, we can just walk around with your resume, you know, you're going to be picked from the air basically. So it just requires some networking.
Yeah, I agree. Go ahead, Jeffrey.
Yeah, no. So yeah, I will echo everything Paula said. It's we are hiring all the time, and what I'm experiencing over the last 5 years is that the renewable energy industry in a whole is fairly young, and it is constantly evolving, developing. There's newer technologies getting more efficient, and the engineering experience that that's needed with renewable energy is just not a lot out there, and the people that have that experience are just highly sought after. And so the industry is in a lot of churn right now, where people are just kind of moving from one company to another, and we're having a hard time retaining people. I mean, I have a group of 12 right now, and I have 3 openings, and I'm just constantly recruiting, constantly interviewing, and there's just a huge demand. I mean, I don't think I've ever seen a less than 150 career opportunities open on the Dominion Energy website at any one given time. It always seems like they're always looking for someone, and it's not just engineering, it's safety engineering, it's environmental engineering and compliance, it's government relations and community involvement, and there's opportunities for skilled trades, linemen that are out there in the weather in the middle of the night, trying to make sure that they do storm restoration, and there's a lot of supervisors that support them. And we truly treat every customer as if they're our last customer. We want to make sure that every single person has available power to their home, because we understand how important that is to the safety of their family, and to keep them warm and cool when they need it. So we're just constantly looking for people. So anyone interested in the engineering fields, whether it's civil, electrical, mechanical, IT, environmental engineering, go for it, because we are only moving in that direction and only need more as the years come.
Yeah, I can't be the only one here that like panics when the power at my house goes out, and I'm like, oh, when is it going to go back on? Right. Then I log online and I realize that like 20 people have already reported the power outage like as soon as it happened. So like, it's definitely a lot better. Technology has made things a lot, easier in terms of dealing with the power outages and whatnot. So yeah. Your work is appreciated, Jeffrey. Okay, so our next question is, what about burnout? So do you all feel like your field, the STEM professionals in your field experience a lot of burnout? That's
actually a really good question. I'll actually take that one. So the reason I left Ford Motor Company after 10 years is because in manufacturing, if the plant's not running, the company's not making money. So the manufacturing plants, no matter what you're manufacturing, it could be computers, it could be vehicles, cars, they just can't seem to make enough, because everything is streamlined, it's condensed into facilities, so they can maximize the dollar that they spend to get the benefit of that dollar back out. I was working 100 hours a week, and I did that for 10 years. And you think about it, 100 hours a week, that's a lot of hours. I felt like I was working 2 full-time jobs. It just happened to be at the same place. My longest shift, one shift continuous, is 39 hours. We had a problem in the plant, and the plant went down, and I had teams rotating 24/7, and I couldn't leave until I got the plant up and running. So after 10 years, you're right. You can get burned out. I was burned out. I can't remember what I did on vacation. I can't remember, what I even did on my birthday, or what I did at Christmas or a holiday. It was just crazy. And at Dominion Energy, we support, keeping our people safe along with our community safe. We have limits on how much time, we can work out in the field. And so we have enough people to support 24/7 operations. So even the people that you see restoring energy, during outage times, like when storm damage restoration is going on, we limit the amount of hours that they can work and support you. So, but yeah, it's very possible, but we do everything we can to eliminate or limit burnout.
Yeah, I would echo that too. Working for engineering consulting is not as bad, but definitely there's times, like I said, a wastewater treatment plant, the water just keeps on coming and you got to keep it moving. And when we're doing a startup, we're trying to get a process up and running. There's definitely, long days, long hours, also when there's deadlines. And sometimes you kind of have to cram, all the disciplines are not ready and you just have to like deliver by a certain date to the client. There is long, definitely long days, long hours.
And do look out for the May 2022 newsletter, which will have information about the Repicture Scholarship, where you can apply and hopefully attend that summer program. So thank you so much for everyone who attended. I hope that this was informative to you all, and we hope to see you at the next Lyceums event. Bye, everybody.